Hi everyone. We are going to now make the big connection. We're going to connect real world problems to the standard normals so we can answer just about anything we'd like to using normal curves. If it's a normal curve distribution of any kind, we can make and figure them out. So I'm going to remind us that one problem we were working on with our light bulbs, just because then we can have some connection between that and what we were doing and make the big connection between all of it. So the problem we had was that the lifetime of a light bulb was normally distributed with a mean of, where's my number, 1495, and a standard deviation of 22.5. Okay. When we were doing the empirical rule, we found that we had those magic numbers. I'm going to quickly put them back up here again, and just so we can remember what they were. So again, standard normal means that we can draw the bell curve, or not standard normal, sorry. Normally distributed means we can draw the bell curve. And we know from the bell curve that our middle is going to be this mean, our median, and our mode are all found in the middle. And if I start adding on the 22.5, I get what I called as those magic numbers. So this 15, 17.5, the 1540, and that 1562.5. And we can also then subtract, and we get that 1472.5, we got 1450, and 1427.5. And the empirical rule allows us to pretty much answer any percentage questions we might want to know using those values. Today we're going to figure out what happens if I want to realize some other number. So say I want to know what percent of light bulbs last longer than, let's say, 15-30 hours. Okay, to do this, I'm going to always draw my pictures. And so I'm going to draw another uncluttered picture. Again, I always will put my middle in here just so I can use it as reference. So I want to put in that 1530. So that 1530 is on this side of the 1495 because it's bigger. And I want to go lasting longer. So that means it would be looking at all of these guys up here. We will notice that this 1530 is not one of our magic numbers. So we cannot use that 68, 95, 99.7 rule. But what we can do is what I like to call is we're going to standardize this value. And that word standardize is kind of something I've been using in my teaching career. It seems to make sense to me. I'm hoping it makes sense to you, because what we're going to do is we're going to transfer this number to the standard normal curve, which has a mean of 0, standard deviation of 1, so that I can then use the table that we had in the last video, which of course is someplace in my pile here. Okay, found it. To standardize this video, what we are going to calculate is something called a z-score. Not that that matters, but it is called a z-score, so if you're reading someplace else or looking at other statistical information and they talk about a z-score, it is just some standardized normal score. To calculate that z-score, we take the data value that we're dealing with, we subtract off the mean of our information, and then we're going to divide by the standard deviation. I'm going to abbreviate that to standard dev. So it's our standard deviation. So for this 1530, we're going to take our 1530 minus our mean, which is at 1495, and we're going to divide that by a 22.5. And I'm going to get my calculator to do that. So I'm going to calculate the top number first. So that's 35 over my 22.5. So then divided by 22.5, and I'm going to get this really ugly number, but it's 1.555, and it keeps going on and on and on. Okay. We will be rounding to 2 decimals because our table uses 2 decimals. So we will round this as normally. So the 5, we'd look at this guy, round up, so it's going to become 1.56. So what we have done is we've taken this 1530 and we've turned it into our standard normal curve. So I'm going to draw another little picture here. So here's that 1495. Here's that 1530. If I standardized the 1495, it would turn into a 0 because I would be taking 1495 minus 1495, which is 0. This guy turned into 1.56. It's not going to look exactly the same, but for our purposes, it's okay to draw them the same. Now, instead of having new tables for every single situation, I can use my standard normal curve that I learned in the last video, and I can look up the 1.56. Okay, looking up my 1.56, I'll remind us how we do that. So here's that standard normal table. 1.5, go over to the 6, and I get 0.4406. So I'm going to write that down, 0.4406. And remembering that the table gives us from the center to that point. So here's my 0.4406. So if I want to find the tail, I have to remember that from the center all the way to ever and ever forever is 50% or 0.5. That means I want to take this 0.5 and subtract this whole thing and get rid of this piece here. So subtract. So take my 0.5, subtract 0.4406, and I come up with 0.0594, which is 5.94%. Okay. All right. Then we'll do one more, and then I'll kind of summarize everything for you. Let's find the percentage of light bulbs that will last between let's go with 1430 and let's go with 1545 course. Okay, and these are kind of the steps that I would go through. So of course this problem would have more information that we were given before, but again I'm going to start by drawing a picture. It is normally distributed, so I would draw a normal curve. It has a center or mean of 1495. So I'm going to put the 1495 in the middle. Then I'm going to put these values in reference to this 1495. So 1430 is on this side because it is smaller. 1545 is on this side because it is bigger. And we want to go between. So I'm going to draw these little lines and I'm going to shade between. Okay. Our next step is to standardize the boundary values. So here's the steps that I've gone through is we draw the curve. We label the center. We place values of question. In picture. And then we shade area of interest. Okay, so we drew our curve, we put in the 1495, we labeled those values, we shaded where we're looking. The next step is to standardize the boundary values. Standardize boundary values. All right, so we're going to take our 1430 and our 1545 and we're going to standardize them. Again, to standardize, we take the value minus the mean and divide by our standard deviation. Okay, so we'll do that to this guy as well. Value minus mean divided by standard deviation. And then drag out our calculator. 1430 minus 1495. You will notice you get a negative value. That is to be expected. The negative tells us that we are smaller than the mean. That's all it tells us. And then dividing by 22.5, I get a negative 2.88888. So rounded to 2 decimals is a negative 2.989, sorry. 1545 minus my 1495 gives me 50 divided by 22.5. Again, this one will be positive because we are bigger than the mean. And I get 2.22. And it goes on forever, but it's rounded to 2 decimals. It's 22.2. Our next step is to look up those values on the table. Okay, remembering that when we look up negatives, we just really look up the positives, and remember it is symmetric. So this guy, we're going to be thinking of it being up there. So I'm going to look up 2.89 and my 2.22. Okay, trying to get it all in there. 2.22. 2.22 is 48868. 2.89 0.4981. Okay, and then what we are going to do is use the picture to get our answer. All right, what I mean by that is to remember what the table gives us and use the picture to tell us what to do with these two numbers. All right, the table gives us from that point to the center. So from the point to the center. From the point to the center. So our 289, that was this guy. That 4981, that is here, 0.4981. Our 0.4868 is over on this side. 0.4868 is on that side. In this situation, we want to get from here all the way to here, so we are going to have to add those two. And so that would be 14, carry a 1, 18, carry a 1, 0.9, which is 98.49%. Okay. These steps are the exact same every single time. The steps that you do on this last one will be very similar to what we did in video 2. If they're on either side, we will be adding. If they are on the same side, so let's say we have a picture and we've got two numbers and we want between these two. One time we look it up will give us this value, the other one would give us this value. So to find between them, we would subtract. If we have a tail that we're looking at, we did one at the beginning, but let's say we had a big tail and we wanted bigger than this. The table will give us this value. So this is from the table. What we will need to do is add on this piece, which is 50% of our data, or 0.5. So here we would add those two pieces. I hope that these videos help make this material a little easier. Please email me with suggestions, ideas, comments. If these helped, let me know, because then I'll keep them. If they didn't help, let me know, and I'll scrap them. Thanks for everything through these times. I hope all of you guys are doing well. Please let me know what I can do to help you. So have a great day. Talk to you later.